Hi everyone, this is the new video in the Docker tutorial series. I'm sorry you guys had to wait so long. I was pretty busy. I was moving from one assignment to another assignment, so I was basically changing jobs, and I'm just in the middle of that process. So I'm quite busy, but I received a lot of positive feedback from you. A lot of views, over 40,000 views on the getting started video, and a lot of likes, like over 400 already. So thank you very much. I got a lot of positive comments and a lot of questions. And yeah, many people were asking me to create a video on Dockerfiles, on Docker Compose, and Docker networking. So this is exactly what I'm going to do. First of all, we're going to start with the Dockerfile. And today I will explain why you want to use a Dockerfile. I will explain about the work, the process of building a Dockerfile when you have to build, or you want to build one for your project. And we will look at some samples, examples that we will create together. Plus, I will show you the documentation, on how to do the Dockerfile itself. So this is what we're gonna do. And well, let's get started. So let's start with the first question. Why you want to build a Dockerfile, or what is the benefit of working with Dockerfiles? And the answer to this is, when you start up a project and you use a Docker image, so you go to the Docker store that you see on the screen here next to me. If you go to the Docker store, you will find a lot of different images, and you can use those images to start up containers. And please look at the previous video. If you haven't seen my video, look at the video, because in the first one I explained all this kind of stuff, how this ecosystem is building up, but I don't want to spend much time on that today. So specifically for the Dockerfile, if you go to the Docker store, you will find a lot of images that you can use to start up containers. And in those containers, you will have operational and runtime environments for your project. Now the thing is that there are images on the Docker store for almost everything, really. So you have base images for Linux distributions like Alpine or Debian. You have images for PHP or Python or Node.js, or whatever you can think of. And you have web servers and so on, databases of course. But none of these images is really exactly the thing that you need for your own project. So you will very soon realize that you will need something more. So you might want to set up an environment. For example, if you work with PHP, then you need to install a micro framework or a framework like Slim or Laravel or whatever, WordPress, for example. And in those cases, you have to add something to the images that you can download from the Docker store, or you can pull from the Docker store. So in this case, what you need to do, you need to build your own images. And that's where the Dockerfile comes in, because the Dockerfile is basically the definition of a Docker image. So the Dockerfile itself physically is a text file, and we're going to create a text file very soon. So I show you Dockerfiles. So Dockerfile is a text file that is called Dockerfile without an extension. And then there are certain instructions that you can use inside the Dockerfile, and that's the way you build up your Docker images. And then once your Dockerfile is ready, then you use the command docker build, and docker build will build the image from your Dockerfile. So that's the process of going from the file to the image. This process is called building, and you use the docker build command to do that. So in order to get started, let's have a look at let's have a look at a few images, and I will explain a couple of things about the Dockerfile. So for example, let's take the PHP. I'm going to use in this video, I'm going to use PHP, Node.js plus Alpine Linux as a base image, and we will play around with those. So if you look at PHP, for example, this is the official image for PHP. And if you look at this, you see that there are a lot of different variations and versions and all this stuff here. So this is the PHP version, as if you look at it first here, and then there is one that is based on Alpine. There is one that includes an Apache web server. There's a command line interface and so on, and there are different versions here provided. So 7.1, 5.6, I think you get the idea. And if you look at the end of every line here, you will find the Dockerfile. So I'm using this version right now locally. So let's look at the Dockerfile. So the Docker file of that image on the Docker store is available on GitHub. So most of the images that you can find in the Docker store have a link that is pointing to the Docker file on most of the time on GitHub. So if you look at this file, for example, then you can see that this image is based out of Debbie and Jesse. So the from statement here denotes that it's coming from Jesse. And on the next line, you will see that there are some environment settings. They're running some command line commands here. And then we will set more environment stuff. We create more directories, configuration, and so on. So the Dockerfile, basically, you don't need to understand this right now. We will move into that later. So the Dockerfile essentially describes step by step, how to build up a runtime environment within the image and then in the container. So the thing is that whatever is included here in this Dockerfile, that's gonna be available in your image. So for example, if you use the PHP image here, then you see that some base Linux packages are already installed. So if you want to do some curl, then curl will be available in that image. But for example, if you, I don't know, let's see, if you want to use Git, for example, with PHP, then I don't see Git anywhere here. So you will probably not be able to do a Git pull in that image because Git is not available here. So then what you need to do, you need to add install Git into a custom image so that you can do that for your work. And that's when you create a Docker file and you use this PHP image as a base image and add some stuff to it. So to make it more clearer and better, let's start with an Alpine modification. So I created a playground folder here on my machine. We're gonna use the terminal, of course. I guess this is a beginner's tutorial, of course, but I don't want to explain, what a terminal is. I assume you guys know these things, and I assume you know some minimum command line stuff, like like listing. This folder is empty, and I'm using Z shell, so please bear with me. I'm using commands like ll and stuff. Okay, so I get the playground, and what I'm gonna do, first of all, let's see my Docker images. So these are the Docker images that I've already pulled from the Docker store, okay? And you see I have a lot of stuff. Okay, it's not too much actually, because I'm trying to keep the stuff clean. Well, I have Alpine 3.4, and this is what we're gonna use. So we're gonna create a new version of this Alpine. This is an Alpine Linux distribution. Okay, if you look at the size, this is less than 5 megabytes. And if you look at some of the other images that I have, if you see like Node, for example, is another official image, and you will see that there are some images that carry my name, and these images were created by me. So these are already custom images that I created with the Dockerfile. And if you look at this one, this is like 2.1 gigabytes. So some stuff really takes up a lot of storage space. So that's why I'm trying to minimize the number of images that I'm storing on my machine, because they take a lot of space here. So I have one for PHP Slim, for example. This is something that I also built for myself. Another one, this is what I'm using for my blog here. This is a Jekyll image. This is something that I'm using for a PHP fat-free micro framework image. I have the official WordPress, I have the official Jekyll. This is the base image of this one here. I have official PHP, including a web server. I have MariaDB, I have an Nginx proxy, and well, that's all. Now, okay, so in the playground, let's just create a Docker file. So this is your first Docker file, and then let's use an editor to edit that Docker file. Okay, so this is our beautiful Docker file, and what we're gonna do, we're gonna use the Alpine image here. So this guy here, Alpine 3.4, and we're gonna add some stuff into that. So what I could do, let's play with it a little bit. Okay, so let's start up this this image here in interactive mode, and --rm is very important because once you exit from this container, it will be automatically removed. I'll show you why. Because if I do a docker ps, nothing is running. If I do a docker ps -a, then you will see that these are the images that I used to run, but they are not running anymore. So these are the ones that I started up, and I can restart anytime. Okay, so if because I started them up in a way that they stay around, but if I use --rm, that means once I stop those containers, they won't be staying around here. So you know, I'm trying to create less mess. Okay, so Docker images again, and so let's go like docker run -ti -rm, and then what I want to do, I just want to very simply start a pine 3.4, and I want to run a shell. Okay, so what happens, I am inside this container and I am root. Okay, and so let's see what this stuff has. So let's git version. Yeah, it doesn't have git. Let's go vim. Doesn't have vim. Curl is not available. wget is available. Okay, so let's do the following. So there's no git, there is no vim, there's no curl. So let's create an Alpine image that has git, vim, and curl. Okay, so that's what we're gonna do with our Dockerfile. So let's leave this container. Okay, and then if I list my containers, you see it's not around anymore. So that container is gone. I didn't create a mess, which is good. Okay, so again, let's list the images. This is what we've got. And let's create our first Dockerfile. Every Dockerfile must start with from. From means that we need to pick a base image. You can pick an existing image from the Docker store, or you can build your Dockerfiles from scratch as well. And yeah, you know, every image needs to start somewhere. So you can build your files from scratch. But for now, in the beginning, let's use an existing image and let's start from that. So if I say from Alpine 3.4, that means that I'm using that image that we just looked into in the command line, and I'm going to add some stuff into that. So there is another keyword here called maintainer, which is not so very okay, it's important, but it's not critical. But what I usually do, I just put my name here and my email address, so anybody can find me and send me emails and stuff. So I'm the maintainer of this stuff. And what I'm gonna do a run, and this is gonna be really interesting now, because the point here is you need to understand how the Dockerfile is building up. So let's add some instructions here, and then I will explain what's going on. So we're just gonna use the package manager inside Alpine, and then we're gonna add some packages. So let's add vim, and let's add curl, for example. Okay, so this is, by the way, not best practice. This is something that I want you to see. So let's do that. So if I list this, there's one Dockerfile here. So what we need to do right now, we are going to build that image. So what we're going to do, docker build -t means that we give a tag, which means that we're going to give a name to our image. And you know, every image is named in a way that there's a provider or creator or maintainer, and there's a slash, // and after the / there's the name of the image, and then you have some tag for the version and so on. So what you usually do, I give it my name because I'm the creator, and let's say that this is gonna, let's call this Alpine whatever smarter, and then this is gonna be version 1.0, and we need to provide the location of the folder that we are building. So we put a dot, which means that we are building the current folder, and Docker build, we look at this folder and look for the Dockerfile. And if it finds the Dockerfile, it's going to build it. So let's see what happens. Now this is pretty interesting, and yeah, I'll show you why. Let's wait a bit until it builds. I hope my internet connection is up to speed today. And you see that we already see that some steps are created here. There are 5 steps altogether, and 1, 2, 3, 4 is happening right now. And yeah, while we are waiting, let's go back to Dockerfile and see. So there's 1, 2, 3, 4, 5. Interestingly, so the 5 steps that you see in terminal are related to the 5 steps that are on this on the lines of the Dockerfile. And this is going to be pretty interesting. So if you look at this here, step 1 is exactly this line here from that you see there. And then what it did, it says there's this little arrow symbol and there is an ID. So after this executing this line, we have created this Docker image, and I will show you those images in a minute. So what's happening is that for the first line, Docker created an image, and this is sort of an intermediate image. Then for the next line, maintainer, which is me, it created first it created an intermediate image, then it created another image, then it removed the intermediate container, and then it ran the next line, and at the end of the next line another image was created. So what's happening is, we are installing also here and installing also here. So if we go do Docker images right now, we will see that we created something called Alpine Smarter version 1. Okay, now if you go Docker images -a, that will give us more images. You see here. And what's happening here is that these are intermediate images. And if we go back here, you will see that the IDs, the image IDs that we can see in terminal, are the same as we can see here. So the final step, step 5, created the CE1A and so on. CE1A and so on is the ID of the final image. Then the step before should be C497B. So C497B, you see, this is the end of step 4 is C497B, and the end of step 3 should be this 340A, and then this one here should be 0D something, you see? So the thing is, and the first one, this one here, it's not listed. So every step going backward produced an image, and every image is stored on your system. So these lines, every line that is highlighted here is a Docker image. Only the final one has a name, a proper name and a proper tag, but every line that is untagged here is also a Docker image. And you see the size, the sizes are different because as you add stuff to the images, the size will grow. So, and this has a couple of implications, but let me show you. These are 4 steps. So the step 5, step 4, step 3, and step 2. So where is step 1? Step 1 says from Alpine blah blah blah, and it says the ID is BAA5D and so on, and that should be the base image. So if we go and find Alpine here, BAA5D blah blah blah, you see here. So that image from the line that says from Alpine 3 to 4, that is this one here, and that's the ID that you see up here. I hope this makes sense. And so what's happening here is that for every line in your Dockerfile, you get an image. And this is what we call this is basically an image cache, okay? So if we build this image again, and we don't change the Dockerfile, then you get much less output. and this thing says that I'm using cache, using cache, using cache, using cache. So what does that mean? That means that when you build a Docker file, then every line on the Docker file will create a new intermediary image, and that we call image cache. And this will help you a lot because it will speed up your process. Once you have completed some really complex step on your Docker file, and you are adding more, you don't need to restart building the entire image again and again. You can imagine if you have like 20, 50 or 100 lines on an image, maybe like 50, 60, that's already pretty big. Then you don't need to start from scratch or start from the beginning because you can use the cache. So let's play with the cache a little bit. I hope I'm not going too fast. Okay, let's do the short summary and then do the next step. So the short summary, what we have done. We created a Docker file because we are building a custom image for our project. Let's say we want to use Alpine, but we need like Vim and curl inside Alpine. So that's why we have created the Docker file and we have built our own image. So we use that Docker file and use Docker build to create a new image. And then if you go to Docker images, you see that we have actually one image created. I think it's a good idea to test this out because I promised you that we're going to have Vim inside Alpine. We have seen that the base Alpine doesn't have Vim. So let's say like Docker run and then ti, rm, and then Alpine Smarter 1.0 and then bin shell. Okay, and then we go Vim, and you see we got Vim. Aha, cool. So in our Smarter Alpine we already have Vim included. So if we run the build again, then we see that we are using cache to rebuild everything. So now let's do the following. Let's change the Docker file. Okay, so instead of curl, let's say we want git and we don't want curl. Okay, so what happens is that we are rebuilding the stuff, and you see that every step that was not changed here remains. It's still running from cache. It remains the same, and then the last step has been rerun. And then if we do Docker images, you will see that this guy here, we have the Alpine Smarter, and this is the final one. So this is the one that has git inside, because this is what we specified here. And the one that we built previously is here, is this image here. We can check the image ID, and it has lost its name, meaning the tag. It's not tagged right now, because it was supposed to be supposed to have the same name, but right now we put a different content, a different image behind that name. So the original image that we built previously has lost its tag, has lost its name, and it's right now just hanging around. And this is called a dangling image. And this is important for the cleanup purposes. So I show you how to filter that out. So we say Docker images -- filter, and let's say dangling equals true. And you see, this is the only one dangling image. You don't need to learn too much of this magic. This is the only sort of complicated magic command that I use with Docker. This is the way you can find dangling images, meaning that something that you used to use, but then you change your mind, you created something else, and this stuff is just hanging around. So you can actually remove dangling images by saying docker rmi, like remove image, and then you put this stuff into brackets like this, and then if I hit enter now, it's gonna be removed after I put -q here, because -q will remove this heading stuff here. So I'm going to only have the ID. So I'm not going to execute this now because I want to explain something, or maybe okay, let's leave it here. So the only thing that I still want to show you that this is the one, so C1A, this is the image ID that we built before. So our previous Alpine Smarter was this image. So I just want to prove it to you that I'm talking the truth here. So this used to be our Alpine Smarter custom image, but right now that we have a different image because we have built a different image and the previous image is just hanging around. So let's remove it, and now it says we have deleted it. So Docker images, and now the dangling image has disappeared, and let's say Docker images -a, and here you have again the cache here included. And now if I want to build it again, now the entire image is being built from the cache. And why is this important? Because building up your Dockerfile, you need to think of the order that you're doing stuff. So I suggest, and actually this is a best practice, so if you look at the internet, everybody is suggesting the same thing, to do the system level changes and additions in the beginning. Do the stuff that you probably won't change after it's working, do that in the beginning, and then later on put the stuff that might change at the end of your Dockerfile. In this way you can use a lot of cache. Once you break the cache cycle, the cache line, then Docker will rebuild all the following steps. So if I just, for example, say that I want to run, maybe we can add curl here in the third step. So I'm adding another step here. That means that Docker will rebuild the image from this point on. So this part of the cache will be used, but everything that comes after that will disappear. So let's see how that works. You see? So I'm adding curl and I'm adding Vim and everything completely again. It will be rerun from scratch because this is a different image. This is a different state where we are at. So we're gonna rebuild all the following steps after we change the Dockerfile. So that is important. That's why you should think of the structure of the Dockerfile, the order of the stuff that comes in the Dockerfile, because it has an impact on the rebuilding performance. So if I say Docker images, then you see that I have now a new image here, and the other one, the previous one, is dangling. And if I say Docker images -a, that's the interesting stuff here. Then now you see we have a lot of stuff here. Also the dangling part comes into this place here. So if I just, let's remove those and let's go back. So this is Alpine Smarter, now it has everything included, and you have seen that those parts of the file, those parts of the image were rebuilt that came after the change. So there are a couple of considerations here. So first of all, the order that I mentioned to you. Second of all, the size. It does matter how many images you have, because every image takes some space. And for Alpine we are lucky because Alpine is small, but if you look at just one line below here, this image, it has these number, I know 1, 2, 3, 5 or 6 steps, whatever, and every image related to every step takes up like 400 megabytes of my space, and I have a 256 gigabytes of solid state disk. So you can really take a lot of space. Here I'm using Conda, mini Conda. I don't know if you know, it's a machine learning library or like a component, huge framework, whatever. So I'm using mini Conda, and it used to be, the first part was mini, but the last one here, I added a couple of packages here, is 2.1 gigabytes, and actually I have 2 of these here. And then I'm using PHP Slim. Look at this, like 500 megabytes, like 10 times. So this is huge. This is a lot of stuff, and that's why you need to make sure that that you minimize the number of steps and optimize the number of steps. So I show you something. What we could do here, that instead of putting every comment here on a new line, what we can do is that we can actually, oh shoot. Okay, so what we can do, we can put the whole thing on a new line, on one line. So what I'm doing here basically, that I am splitting up this statement, or actually combining the statement to be one line. So this is one line, but I have written that on multiple lines. So that means that right now, instead of creating 5 or 6 interim images, we're going to only create 3 images. Well, actually, this is the base, so we're going to create one, and then this is already going to be the final. So let's rebuild it and see what happens. Okay, let's remove dangling. Okay, there is no dangling, and then Docker build here. So you see, unexpected end of file. What have I done? Okay. I'm sorry. Let's build this again. Okay, so I'm building. Let's wait a minute and so what's happening right now, you see already that is like the total number of steps is 3. It's not 5 anymore. And that means that we're gonna have only one interim image, and that's gonna take much less space. Plus, okay, let's say Docker images-a. So you see, okay, then maybe yeah, the thing is that we have a dangling image, so let's remove dangling images. Okay, now it's gonna be better. Okay, so that's the point here. And after we remove the dangling images, you see that this is Alpine Smarter, and now we only have one image that is less than 5 megabytes in size. So this is one way to optimize. Okay, the downside of this is that if you need to add, so you will probably add a lot more stuff here, and this is only the parts of the configuring Linux, and for example for PHP, maybe you want to install Composer just right after this, and then if you want to change something on the operating system level, then you're gonna rebuild the entire image from this point on. And this is actually we can of course do it like this as well. And yeah, but that's only just a matter of convenience. Yeah, let's rebuild it, whatever. And now you see it's gonna be rebuilt again. Okay. Okay. Let's remove dangling. Let's remove images-a. Okay, so let's do, okay. I have one stuff hanging around here. All right, so I think we have done this part. There is one more thing that I want to show you. It's just, this is really about, structuring the stuff and optimizing the stuff. So let me show you something else, and then we can move on. Okay, so let's do something. There's another instruction that you can see, you can use here. Actually, okay, so let me tell you what is the instruction set for here. So these are the instructions that you can use inside the Dockerfile, and it starts with the from, because as I mentioned before, every Dockerfile must start with a from, so with no exception. This is a must. This is something that you must do. You must start with the from, where you specify the base image for your Dockerfile, and then there's a lot of stuff that you can put. The most used instructions here are here copy and add and run, of course, that we already used. So run is here. You can use like, you know, shell commands, and you can use this arrow format, or you can use just the same format that I use here, same that you would put in your shell or in your terminal. And the command, let's return to the command a bit later because it's pretty important. This is the final command that you will run in your container. And then the maintainer, I have already explained what it is. And the labels, you can add labels to your Dockerfile, you know, for description purposes, and then you can use Docker inspect to see what are the labels here, like version. You see, this is a good example. So it's additional information on the version, description, and so on. Env is important because env, you can specify environment variables here for your Dockerfile. Expose is just the instruction to expose the port. So for example, if you run a web server inside your Dockerfile, that you probably want to expose port 80 for HTTP and 443 for HTTPS. And add and copy, what is the difference? You know, a lot of times I see these questions, what is the difference between copy and add? Both are used to copy files into the Docker image. So that means that the image itself will contain, so it's not the container, not the runtime, it's the image itself that will contain some sort of files. So for example, like configuration files or environment files. And the main difference between copy and add is that add can do a little more because you can use URLs in add. So if you add a URL, then Docker will actually retrieve the stuff from the internet for you, and add can also use zip compressed file and tar files you see here. So you can add a tar file and then you know, it will decompress and copy that into your image. So copy is just the same thing, but it doesn't do URL and doesn't do compression. And yeah, user and workdir, I can also, these are the things that we also usually use. Right now in this basic example, I'm not using it. The user, you can set the user ID, so you can switch the user, you know, because if you don't want to run as root, then you need to specify the user. And the workdir is pretty important. You can set the working directory. So whatever whatever instructions you have after the workdir, they will be executed as in that context. So your working directory will be that directory that you specify there. Okay, so I don't want to talk about the others right now, but this is basically the instruction set that we use inside the Dockerfile. And with these things, you can basically complete almost anything. So this is a pretty cool stuff. So let me show you something. So what I want to do, I want to copy one file into our Alpine container, or Alpine image. You see, sometimes I also mix up the notion of container and image, but right now we are building an image, so let's do that. So let's assume that we have something like a config text file, and then let's say whatever, blah, blah, blah. Okay, so this is one text file, and what I want to do, I want to copy config.txt into my container. So let's say set user search source. So into this, I want to copy that file into my image. Okay, so let's go and build this image. Just let me see, Docker images. Okay, right now I'm fine, and let's do the build. Okay, so you see I have copied that file inside here, plus I have executed this command here, so I've successfully created it. So let's now say Docker images. Okay, we have this dangling stuff around, and then I'm removing it. Docker images, fantastic. So let's go like Docker run. Let's look into this image here. Okay, and then let's see. There you see we have config.txt in here. Config, okay, sorry. Okay, so what happened is that I have copied that config.txt into my Docker image. So if I start up a container here, then I see the stuff happening in here. And yeah, this is what I suspected, that something was not working. Yeah, it's not working because that's my fault. Yeah, that stuff was sorry. This is just a typo, but you know, it won't really change the idea behind. Nah. Okay, so now I'm installing. Yeah, I just made the wrong step. Yeah, sorry about that, but I think you understand the point. So now I fixed this. Okay, so the thing is that so right now I'm not running anything anymore. Okay, so let's go back here. So now the image is done. Docker images here. Okay, let's remove the dangling again. It's a bit tedious sometimes, I can tell you. So Docker images. Now let me show you something important. Okay, so now we have this smaller image and we copied this file into here. So let's rebuild it just to show you the everything is done from cache, right? And I have already shown you that if I change this Dockerfile now, then it will not use the cache, but it will rebuild. Now I'm showing you something really important, that if I change this txt file here, blah blah, change. So I haven't touched the Docker file, I just touched this config.txt. And I do a rebuild. Oops, look what happens. Docker understood that I have changed a file that the building was dependent on, and it's rebuilding from that step forward. Okay, so that means that changing the Docker file somewhere in some step will trigger a rebuild on all the consecutive steps, but changing the file that is a dependency of the Docker file will trigger a rebuild as well. So right now I'm rebuilding, and if I say Docker images, bang, you see I have the dangling image and I have a new image here. And that new image contains this change already. So we can, of course, okay, let's type it, Docker run. I don't know. Yeah, let's do that. I mean, it takes some time, but I don't care. Let's do this. Let's not be afraid of this. I know everybody wants to have quick learning, quick information. I'm just talking and talking and doing this recording. But sorry, yeah, let's do that. Let's have a look at it. Okay, so use source and config.txt. You see, and there is the change already inside. So now we have learned a lot of useful stuff. I think this is the essence of working with the Docker file. What I have shown you in the last, I don't know how many minutes already, like 20 or whatever. What I have shown you so far in this tutorial is the most important thing that I think you should understand, or based on my experience, this is the most important thing. That as you build the Docker file, then for every line or every instruction, you will have a new intermediary image. And if you don't touch those lines, then the cache will be used. If you touch those lines, then the image will be rebuilt. Okay? And this is important because you need to think accordingly. If you want to really deep dive into the instructions, then you can find the documentation. This is pretty easy to understand anyway. So you're gonna, building the Dockerfile is actually building up your environment. It's the same thing. So what you are doing is you're building up a Linux development, test, or production environment. So you need to understand your subject. If we are building for Apache, you need to understand how to configure that and what are the steps that are required, how to install the stuff. All this content you need to understand. But the Dockerfile the Dockerfile just gives you a way to enter all that information that you should actually know. So Dockerfile is a very simple tool. What is important to understand about the Dockerfile that it has a cache, it creates layers, and it really does matter how to set it up, how you set it up. And you can, it also understands whether you change a config file or you left the config file unchanged. So this is something. So far we have closed one big chunk or one big step, big chapter in the Dockerfile that I wanted to explain to you, and I think you are ready. You can leave this tutorial right now or you can stay with me and I show you my work process of building a little bit more complex Dockerfiles, first of all, and second of all, then we're gonna add more and play with some more Dockerfiles as well. So we're going to create a PHP Slim Dockerfile, and after maybe we'll also create another one for Node.js, but maybe you can do that for yourself as a homework.